require? How much transistors you require? One transistor can store 1 bit. So for storing 8 into 10 power 12 bits, how many transistors you require? 8 into 10 power 12. See the number is very huge, and the size of external hard disk is size of your palm. So technology is making it very, very simple for you to hold so much millions of transistors inside your palm. So you have to be very, very astonished by the technology, how it is making devices very, very smaller and smaller, right? So this BJT has lot of application, especially memory. So whatever memory device you are going to use or memory device you are going to purchase, everything will have everything in the end, it is going to boil down to BJT circuit only. And inside BJT, you have diode. So everything will boil down to N-type device and P-type device. So that is the basics of electronics, what we studied in the last semester, right? So that is why we see the application of BJT is very wide. It is used in computers, in memory devices. It is used in satellites as an amplifier, and all modern communication systems are going to use this BJT extensively in a wide variety of applications. And BJT has one problem or one drawback which FET is not having. Can anybody say what is the drawback BJT is having which FET is not having? That is why FET is becoming more and more popular than BJT nowadays. So can anybody say which property of BJT is going to be the drawback for it?
It has a lower gain bandwidth, sir.
Okay, to some extent, good. One important thing, which BJT is affected, which FET is unaffected. The very first thing I told, which parameter is going to dominate the performance of a semiconductor device? Temperature, yes. BJT, the dependence on temperature is very, very high, whereas FET, I will not say it is completely independent, but the dependence on temperature is very, very less. So if the current is going to change 10 times and the temperature is changing in BJT, whereas in FET, the current will change only by 2 times. The variation in current is very, very less in temperature, right? So that is going to be the only drawback. But barring that drawback, BJT is very extensively used in all the applications. And when we are focusing on using a BJT as an amplifier, you should ensure that the transistor is working in the active region. See, active region is going to be the complete region. You cannot clearly understand what is the active region. You cannot clearly mathematically say what is an active region. Region nale, it means that some undefined area, right? If I want to clearly state that my transistor is an active region, I need to have a coordinate or a point which says that if I mention that, if I say that coordinate x comma y, I can say whether the transistor is in active region or not. That coordinate point is called as quiescent point. See here, QUIESCENT, quiescent operating point, or it is called as quiescent point, or in short, it is called as Q point. So any transistor which is working in the active region, it will definitely have this Q point. And what is the form of representing Q point? Q point is just like any coordinate system. It will have two coordinates, x and y. Okay, it will have two coordinates, x and y. X is going to be the voltage, y is going to be the current. So understand that when this Q point is not applicable for saturation and cutoff region, it is applicable only when the transistor is operating in the active region. Why we need this Q point means because Q point will identify, from the Q point we can easily conclude whether the BJT is in active region or it is in saturation or it is in cutoff. So Q point will have the format x comma y, and x is going to be the voltage, y is going to be the current. Okay,